Hey guys, this is video 8.3. We are now going to talk about gram to mole conversions as well as mole to gram. So we're going to go gram to mole first and then go backwards from there. We're going to be on page 7 in your notes. So now when we take a look here at our T-chart, our roadmap that we're going to use, we know that this is what we had before in the last video, 8.2, where it was just mole to mole. Now we've added one extra piece over here where we're going to take it one step further. We're not just going to end with moles of a new substance. We're going to go and finish to grams, which this last step right here, okay, this is a review. This is from Unit 3, so we're taking what we learned. This is the mole-to-mole stuff, that converting from one substance to another. That's the new piece in this unit. That's the new one. Everything else that we're adding on now is review. That last step, or the beginning step as you'll see, is review from Unit 3. Okay, so this last step here is Unit 3. So if you don't remember how to do it, you got to go back and look at your Unit 3 notes. Like, where do we get grams from? And notice it even says here, it's the molar mass of our substance. So let's jump into an example problem. You know, some of you guys in class already have said, oh, is it really this easy? Is it going to get harder? Guys, when we look at each of these types kind of individually, one at a time, they're pretty straightforward, pretty simple, okay? It's when everything is mixed together after we do all four types, that's when things get confusing and get challenging, okay? So you've got to make sure you practice. It's not enough to just do the example problems here in class. So before you take your quiz on the mixed stoichiometry problems, you need to make sure that you do practice sheet 4, which is everything all mixed together. But more of that coming up later. Let's get into the material here. So again, we've got our given, all right, which we were given in this case, 13 moles of aluminum oxide, and then we're identifying our wanted as well. Okay, so how many grams of O2 can be produced? So if we have a starting material, we can figure out, well, how many grams will we actually end up with? So this is something that chemists all over the world and any chemical plant, so if you think about something like Kodak or Procter & Gamble where they're producing different things, or someplace like Pfizer that's making different medicines and things like that, they're doing these types of calculations on a daily basis that govern and guide their reactions that they actually produce on the floor. So that's why this is so important to us. So if we take a look here, we're starting with moles, so we're starting right here and we're trying to get to grams of our wanted. So it's going to be what I call a two-step, or you may think of it being 3 because there's 3 separate fractions, but that first one is just our given stuff. So we're going to have 13 moles of aluminum oxide. We're going to get things all set up. Remember, put the number 1 down there as a placeholder so you don't get confused and start putting other stuff in there. Then I want to cancel moles out. So moles of aluminum oxide are going to be on the bottom, and that's going to allow me to transfer from one substance to another. So on the top here is going to be my moles of my wanted. I'm trying to go from aluminum oxide to oxygen. Okay, so this right here, what I've already written, is what we did in the last video, 8.2, the mole ratio aspect. Now we're going to take it a step further, though, and we're going to add that extra fraction to go from moles of oxygen to grams. So moles will be on the bottom. And notice, guys, as I go through these problems, I'm setting all of my units up first. This is what I mean, again, when I say let your units drive your math. I can get all my units set up before I start worrying about the numbers or the math that's involved. Okay, because I can see now, oh, clearly moles of aluminum oxide are going to cancel out. Moles of oxygen are going to cancel out. I'm left with the target unit that I want to end up with before I even worry about numbers. Get those set up first, because now we can go back and identify what numbers I need. So back here in this middle fraction, okay, I've got my mole ratio. So where do I get the numbers from for that? Think to yourself, where did I get those in my last video? Well, I need my equation. So it says using that same reaction. So that reaction that I have been using all along is Al2O3, or 2 moles of aluminum oxide, breaking down or decomposing into 4 moles of aluminum plus 3 moles of oxygen. That's where I'm going to get my numbers. So I'm going to take a look. Okay, aluminum oxide, I've got a 2 in front. Okay, that's where I get my number there. Now for oxygen, I've got a 3. So again, this isn't anything brand new in this video. We did that in the last video. Okay, so now I can go through and do this last step. Notice, guys, that right here, and this is again review from Unit 3 when we did this prior, when you have grams of one substance and moles of that same substance in the same fraction, mole is always going to get 1 because this is just your molar mass. 1 mole of oxygen is a certain number of grams. Well, think to yourself, how do I calculate molar mass? I've got to look at my formula. So I've got oxygen. I've got 2 oxygens. So I would look up and see, on my periodic table that the mass of oxygen is 15.9994 grams, and I'm going to multiply it by 2 because I have 2 oxygen atoms. So essentially that's going to be 32 grams of oxygen that I have right there. Okay, and that is where I want to end up. So now I can just put my equal sign, and now I just have to do the math. Remember, guys, you don't have to, you can just plug all this into your calculator, but you can also go through and simplify it if you want to, which is what I'm going to show right here, because I can just, get rid of this, then I don't have to divide by anything. 16 is going to be on the top, so really all I'm doing is 13 times 3 times 16. My final answer that I get is going to be 624. I'm going to round that to my original number of sig figs. Original number I had was 13, so that's 2 significant figures, so my final answer is going to be that same number of sig figs, 620 grams of oxygen. Okay, so is it really anything completely brand new? No, guys, it's one extra step from the new piece that we learned with the mole ratio, and that's a review step from Unit 3 that we're just tacking on at the end. So I would encourage you guys to pause the video, try this problem, and then come back and check for the answer. All right, so here we go. I'm going to kind of not really write by color this time. I'm just going to kind of write them down. Given, I've got 3 moles of oxygen. My wanted is how many grams of aluminum. Okay, so I'm going to set it up. Write down what you're given to start with. 3 moles of oxygen. Put a 1 right there. So everybody should be able to get to that point, no problem. Okay, now think about what you're trying to end up with. I'm trying to get to grams of aluminum in the end. So not only am I going from moles to grams, I'm also going from oxygen to aluminum. I got to transfer substances first because I have moles to start. So moles of oxygen on the bottom, moles of aluminum on the top. This is going to allow me to go from one substance to another. So again, I'm going to look at my equation, but I'm going to get all my units set up first before I start plugging in numbers. For me, that works easier, so I'm not as confused. I like getting one thing taken care of, I know I'm on the right track, and then I can get my numbers worried about after. That typically is the easier part for me. So moles of aluminum will be on the bottom, and then grams of aluminum are going to go on the top. So all my units cancel out. This is the unit I'm trying to get to in the end. So now I can just go back and plug in my numbers. Well, if I look up here, I had 4 moles of aluminum from my balanced equation, and I had 3 moles of oxygen from my balanced equation. When I have moles and grams in the same fraction, mole is always going to get 1, because by definition of molar mass, 1 mole of aluminum equals a certain number of grams. When I go to my periodic table, you can round it, guys, to two decimal places. That's fine, and then do your correct sig fig rounding at the end. There's no need to carry 4 decimals out from the periodic table. So that's my math there. Well, I can make it simpler by crossing out those 3's. They become 1. So really it's just 4 times 26.98. So I had 1 sig fig to start, guys. You're never going to have just 1 sig fig. So I'm going to round it to a whole number. 108 grams of aluminum is what you should get. All right, if you have questions about it, ask me in class. We're going to continue on in this video because now we're going to do the vice versa. This is kind of our type 3, where in the last set we went from moles to grams. Well, now we're going to go from grams and end with moles. So it's the same thing that we had back here, except now we have just flipped and brought this part back, and then we've cut it off right here. All right, so that's what we've done in type 3. All right, so again, we are given grams to start, so now we're just going to do that part at the beginning, okay? So let's just jump right in again. Remember, this is our new piece that we've learned. That's our mole ratio piece, okay? But now we're starting with those grams. So here we go. I've got my given. Notice I'm writing that down every single time. That is a good strategy to help you guys and help you stay organized when you don't know where to go. And wanted is how many moles of aluminum. Okay, so let's just write it down piece by piece. Write down my given. Always start there. Put a 1 over my first one. Now we're going to just look at our units. Let your units drive your math here. Grams of aluminum oxide are going to be on the bottom. That's going to get me back to moles of my given substance, which in this case is aluminum oxide. Those are gone. But I don't want to end up with moles of aluminum oxide. I want to end up with moles of aluminum. Okay, so I need one more fraction. So at this point, we have taken care of this. We've taken care of this part down here and this part. So now we've got this last fraction here to kind of figure out. So again, follow my units. I had moles of aluminum oxide right here. They're going to go on the bottom so they cancel out. And then I can go to moles of my desired substance because this is my mole ratio right here. Okay, let's kind of draw that arrow right there. Those are going to cancel out. So now I've got to go back and figure out my numbers. Well, take it fraction by fraction. Okay, this middle fraction, let's think, moles and grams. So 1 mole is always with that, and the grams I'm going to get from my molar mass. Well, this one you're going to have to do a little bit more work for. Okay, so I have aluminum, I've got 2 of those, I've got oxygen, I've got 3 of those, multiplied by their molar masses. This is about 26, this is about 16. So when you add all those up, guys, which again is a review, you should have 101.96 grams of aluminum oxide. A lot of times on a test, especially your Regents exam, they're going to give you that conversion factor, guys. They're going to give you the molar mass. If I give it to you or if they give it to you, use what's given to you because otherwise you're going to run out of time. And then my last fraction here is the mole ratios. When I get those from my balanced equation, which again is this, 2 moles of aluminum oxide breaking down into 4 moles of aluminum plus 3 moles of oxygen. So if I look at my numbers, my coefficients, it's 4 there and 2 there. So all I have to do is do the math. I can simplify 2 and 1. My final answer I should get, I had 2 sig figs to start. So I'm going to round to 2 sig figs for my final answer, and that's going to be 0.49 moles of aluminum. So guys, if you think about it, it's not a whole lot that's different. It's just the rearrangement of it. But if you look at your units, they're going to help guide you along all the way. Let's do one more example like this together. My given, I had 25 grams of aluminum to start. I'm trying to figure out moles of aluminum oxide. Okay, same thing. Start with your given, 25 grams of aluminum. I'm going to set it up. 1 below my first one. Grams of aluminum on the bottom here so they cancel out. Moles of aluminum then on the top. Bam. 1 mole. How many grams of aluminum? Well, when we look up the molar mass of aluminum, it is 26.98 grams. Then I'm going to go over here. Moles of aluminum to moles of Al2O3. Those are going to cancel out. I go up to my equation. 4 moles of aluminum. 2 moles here. And then all I have to do is do my math. All right. When I do that, 25 divided by 26.98 divided by 2, I should end up with 0.46 moles of aluminum oxide. Again, I've rounded to correct sig figs. I had 2 sig figs as my original number, and that's how many I'll report to. You guys go ahead and try the U-Try. You can have me check it in person, or you can check the answer key as well. All right, until next time, see you later.